Today, we are in the defense industry are being treated as enterprises. We have to compete between ourselves. That viewpoint is treating defense as a commodity, come with a cost. And that cost is you're not going to be agile and you're not going to be at the highest quality to compete. I don't want to invent the next best thing. I just want to put my company on the map so somebody can buy it for 10 times of the value and I get rich. That's why always, defense have been the frontier of innovation. And the innovation started trickling down to commercial after that.
Hey, welcome back to the Aerospace Executive Podcast. I'm really happy to have Hamed Kalkali with me. Hamed is the president of Swift Engineering out in Orange County, California. Swift is a cutting-edge engineering house that's doing a lot of prototyping, a lot of future work for NASA, Boeing, Raytheon, Bell. It's got some cool stuff out there. Hamed is the former vice president of engineering for Air Environment, and he's also a professor at Cal Poly Pomona. So thanks for coming on. It's a great background. Yeah, I've enjoyed kind of doing some research on all the cool stuff you guys are doing. So thanks for coming on.
Hi, Craig. Thank you very much for inviting me. It's an honor to be here, and I'm saying hello to your listener as well.
There you go. So, all right. So I'm going to start out with this. We were just talking about it. You guys got a glider. You've got a pretty cutting-edge aerospace vehicle in development, and it's a glider that's at 57,000 feet.
Actually, we reached 67,000 last weekend. Very new.
Talk a little bit about what you can about what's the physics behind that and what.
Well, Swift Engineering is a 45 years old company located in Southern California, San Clemente, founded and owned by Mr. Hiro Matsushita, my boss, who is the chairman and the CEO of the company. We have been always focused on a small niche R&D defense and aerospace product, basically. It started from race car industry. So this project was introduced to Swift about 4 years ago with a contract, a small SBIR contract from NASA and U.S. Forest Services for early fire detection, basically. The idea was have an airplane that can fly perpetually and monitor all of the fire activity on the ground, basically. The only way to achieve this perpetual flight is you have to be above the clouds. So you have access to sunlight 24/7, not 24/7, 12/7, basically. And use the sunlight to charge batteries and use the batteries at night to fly the airplane. And the cycle continues, basically. You might ask why not satellite? Satellites are expensive. Satellites have a small window of being on a location, specifically because they constantly rotate around the world. You might have 10 minutes of window of being over a location. And this product is cheap, way cheaper than satellite, 1% of the cost. You can control the location. You can control the product. It takes off and lands like a regular airplane. But the physics of having something like that perpetually fly with battery and solar panels is something that you have to optimize. Mm-hmm. And results is the best design is a glider, basically. Is a very light airplane, 170 pounds, but with the wingspan of 72 feet, basically. So it takes off. It takes about 8 hours slowly to get to 65,000+ feet, and it stays there, and it takes 8 hours if you want to call it back, basically, whenever you want to call it back. Control from the ground, and it has payloads, so it can provide all kind of telemetry data and video live to the ground and monitor. And anytime you want to change the direction of the airplane, it's very easy to do that. Autonomous, autopiloted, and all the bell and whistles, basically.
That's pretty cool. So it's a glider. So to altitude, small motor?
2 electrical motor.
Okay.
Why that high altitude? Also because above 51,000 feet is called a stratosphere, and the air is very thin. Commercial aviation do not go that high, so there is no interferences between commercial aviation and this type of airplane. So
That's
it makes it perfect to operate it.
That's a pretty, I mean, that's a pretty unique environment. I mean,
It is.
there's not much atmosphere up there. And
No, it is very cold, lots of radiation that you have to cover your electronics and protect them. But once you're there, you're there. No disturbances of wind, no gust wind, and any of those kind of things also.
And that was a NASA project.
It's a NASA project. We actually got a second and third award of another SBIR this year from NASA to continue the project with others. So we flew the airplane. The first time we achieved 25,000 feet 2 years ago. Last year we got to 54,000 feet. And this year, last week, actually, we got to 67,000 feet.
That's pretty crazy. Yeah. I mean, I think about it, being in a G5. Yeah, I flew to G5 once at 50,000 feet.
It's I mean, if you look at our website on LinkedIn, on our page, I posted the pictures for the last flight last week at 67,000 feet, and the view is spectacular.
No doubt. That's pretty, I love it. I love it. You guys are obviously pretty cutting edge. I mean, you're on the cutting edge of technology. You're looking out to the future. Where do you see aerospace today versus where it's going to be in 10 years? I mean, obviously we've gone from commercial air, drones are big, coming in, eVTOL.
Yes.
Where are the opportunities? Where are the challenges?
Yes. So the biggest customer that is concentrated and have money in when it comes to defense and aerospace, of course, is government. And they know what they want, which is great because they tell you what they want and you can focus on it and provide what they need. The commercial side is all scattered around the world, basically. Even the airplane we are working, there are people in NASA that they like to use it for fire detection. There are people in communication like T-Mobile and SoftBank that they are interested in using it as a communication tower in the sky, basically, for remote area, disastrous area, or generally for any country, basically. And these requirements are completely opposite of each other. There is not a single airplane can do the same thing. To give you an example, when you have a 747, with a small rearrangement inside the cabin, you can use it as a cargo airplane or a passenger airplane and satisfy UPS or Delta or American. However, these type of airplanes are designed for a specific mission. So as a result of that, the commercial use of that is going to be delayed, basically, because you have to design it for one purpose, gain some financial profit out of that, use that money to design for another thing. And naturally, the customer with the biggest wallet get the priority, basically, because they can drive the requirement. Now, on the government side, the requirements is mostly focused on defense, basically. Mm-hmm. And one problem on the government side is the financial support doesn't exist. In the past, back to Cold War, whenever the requirement was placed on the table, there was a financial package coming with it, and government would support you in order to achieve the project, basically. Mm-hmm. Today, we are in the defense industry are being treated as basically enterprises. And therefore, we have to compete between ourselves and put our own money to develop something for one single customer, government, who has the choice to pick between 3 or 4 different competing companies. Mm-hmm. And the other 3, they get nothing, basically. So this becomes very scary for a lot of small companies like us. We're 60, 70 people. We never intend to be bigger. We don't want to be that. We're a small niche company, basically. And to spend a lot of money from our own pocket, it's very, very risky, basically. My boss does it to some extent, the owner of the company. A small contract we get from NASA and other places helps. But the results is It's right now we are in the fifth year of program. If the money was available better from the defense sector, we should have wrapped up this 3 years ago, basically 2 years ago. But the resources are limited. And I understand the viewpoint of the government, but that viewpoint is treating defense as a commodity, come with the cost. And that cost is you're not going to be agile, and you're not going to be at the highest quality to compete with other countries and other defense organizations in other countries also. So that is the biggest problem right now in the defense is proper funding. There are very smart people in this industry. There are all the pieces of the technology that have been developed by American company. And to keep it made in America, a system integrator is needed. And that requires funding, basically. As simple as that.
So if the DoD is getting very fickle on the funding, where's all the tech? Where's it all going? I mean,
big companies.
Okay.
Big companies. And the backbone of a lot of innovations are small companies. I work in big companies like Parker Aerospace, Safran, and I know how they operate. And we're a small company. We both contribute to this domain. And both have our own value to this scientific frontier also. But when you start treating it like a commodity, of course, small companies like us have no, competitive edge to big companies like Raytheon and AeroVironment and others also. It's like you want to open up a grocery store next to RAF. There is no, there's no way you're going to win.
Does aerospace start to get like big tech, where
Yes,
where it becomes like a VC, almost a VC model?
Yes,
You've got Archer, Joby, these guys are all basically VC funded. They all went public to raise money. Two will survive.
Yeah, correct. Actually, you brought up a very good point, because now incentive for a lot of small companies in the defense and UAV business is I don't want to invent the next best thing. I just want to put my company on the map so somebody can buy it for 10 times of the value and I get rich. That's the mentality of a lot of small defense companies, basically. And unfortunately, that way, then you're compromising the quality of the design and innovation, basically.
And here's China with deep pockets and
support, and they throw everything. They throw everything on their UAV market. Actually, I was reading somewhere, and I shouldn't quote anything. This is a public forum. I have to be careful without bringing reference. But the amount of the money that China spent from the government on UAV is multiples. I don't want to say the number because I don't remember the reference of what US spends, basically.
Wow. Is UAV, I mean, think about where the world is going and what you guys are working on, be it commercial aircraft, DoD, obviously you've got a UAV for fire detection. Is that where the vast majority of the money is going to go? Is it unmanned flight? Is it advanced product? Is it advanced materials? Or is it both?
Yeah, all of them. But the UAV has proven and has shown its value in Ukraine war, basically, and the recent conflict between Israel and Iran also. And the idea is, how can you have the cheapest drone, and which is the most effective, so you can deploy in thousands without fear of running out of the stock, basically. And to create something like that, it requires research on material, on different technology, and to be able basically to put a system like that together. And China is doing it.
It's an interesting, it's an interesting paradigm. Like I was, we were talking, I was emailing somebody back and forth about the E7, the new 737, the E7 wedge tail, or, versus, the E2 Hawkeye. And the question is, well, heck, I could put a lot of E2 Hawkeyes up for the same price as one wedge tail.
Yeah.
Which do you rather have? Do you suffer? Yeah, maybe you suffer a little bit of capability, but you've got a lot of them up there, and
Right.
it's amazing to me how the world is coming back to a lot of cheap versus, you know, I think Ukraine, Iran or Ukraine, Russia, Iran, Israel has got everybody thinking about, are the next defense platforms cutting edge,
Well,
or is it,
yeah.
or are they cheap? Is it just a lot of cheap? And that's a big
Well,
question.
I tell you one thing. I think one thing that everybody is not talking about it is Russia, with the help of Iran, can afford the 5,000 or $10,000 drone because for them, accuracy of the target and targeting civilian is not a parameter.
Hmm.
Therefore, they don't care. For United States, rightfully, it is a concern, and we want to be targeted accurately and correctly without compromising civilian life. And
Hmm.
that cannot be done with the 10,000 drone. Otherwise, we can make a $10,000 drone in the US, but it's
Anybody
not
could.
going to have, yes, it's not going to have that accuracy.
Uh-huh.
You know?
I got you.
And we have moral value here that we're trying to protect in the world.
What's got you most excited about? Let's put drones and the cheap Shaheeds and the things.
Yeah.
What's got you really excited about? From a
I'm learning. For me, what makes me running is learning. Every day of my life has to be about learning something new. As a matter of fact, I never leave the office. I was telling one of my younger colleague that we just hired yesterday that I never leave the office until I know that I learned something new today from the office. And if I don't know, I will go walk around the floor and find somebody who is working at 6 p.m. or 7 p.m. and ask him, what are you doing? Show me what you're doing. Teach me something. And that curiosity is the reward for me, you know. And I think businesses that are like us should be based on that, not based on financial reward. Financial reward comes second.
you're on the cutting edge. I mean, you're
Yeah.
kind of looking at, your engineering, you've got some tech teams, you guys are looking at things different.
Mhm.
As far as aerospace and defense goes, is it AI? What's the next frontier for people to be looking at? Is it
Yeah.
AI? Is
AI
it
is
advanced
very important.
composites?
Yes, advanced composite AI, advanced composite manufacturing is more important because we are manufacturing composite the same way that we started 35 years ago. In the whole world, by the way, it's not just US. Very labor consumption. People have to do it with hand, slowly, layer by layer. And so far, no new technology came around to make it easier, basically. A lot of it driven by commercial aerospace as well, because once something works in the commercial world, because you're dealing with people's life, the process is not going to change easily, basically. On the other hand, AI on the defense side is important, but and I go to many conferences hosted by Department of Defense in DC, and I think still the concept of AI is not defined exactly. A lot of things that people talk about AI has nothing to do with AI. It's something that has been done in the past 20, 30 years, but the difference is now you have higher speed processor, so you can do it faster. AI, when it comes to collecting the data, is only machine learning. Is nothing AI about it. But it comes to the point that if you want the system to make decision for you and find the best way to complete the mission, that's the AI part. But to do that, then you have to define criteria. What are the best for the mission? The complexity is a human being. When you are a commander of a group and you're out for a mission, you have drones and everything, you constantly can change the goal of your mission and adjust it, basically. Unfortunately, there is not a good mathematical way to put this in a machine, basically, because once you, for example, you put in a machine that I want you to optimize mission for the least amount of fuel spent, then you cannot care about the life. You cannot care about the assets. You cannot care about the endurance of the missions and all of those things. So I think we have to have a definition of how to be flexible about our goals moving around. And that really depends on the AI technology itself. I read a lot of material about that, and I can see the society and the computer science part of AI is really changing a lot from being a fixed target and how the best way to get to that target to coming with scenario definition actually on the AI. And that's the key, scenario definition. Let AI generate scenarios for you that you wouldn't think about it as one person.
Well, I look at it like, we were talking about, I was talking to my wife about AI the other day and Chat GPT and some stuff. And I'm like, I can read when somebody just taps in a couple prompts and then lets Chat GPT write it. You can see it. You can just, you can see, it has a writing style that, you can look at, if you want AI to do the work for you, it's probably gonna fail. But if you want it to refine the work of the human, it's probably a pretty good tool. To think it's going to be a substitute, I'm not sure is going to be. I mean, if people are thinking it's going to be a substitute, I'm not sure that's an accurate assessment. Maybe
no, you're absolutely right. It's not a system with one input and one output, basically. Mm-hmm. It's a system that, yes, you have to create a profile with yourself or your company with ChatGPT, for example, and that's what we do. Mm-hmm. And over the time, build that understanding with ChatGPT of your company, your strategy, your product, your capability, and keep asking questions. And based on the answer you get, keep challenging it, basically. But at the end of the day, you're absolutely right. What is ChatGPT answers coming from? From mm-hmm. other people's and from past. There is nothing futuristic about it.
Right. Well, everybody's just they're finding everything they can and they're throwing it into its learning models and they're learning.
Yes.
That's that becomes a challenge.
So there's still the human power is in deduction, basically, right? And that is still not there.
What about, on the composite side or even the commercial aerospace side of the house? Advanced manufacturing composites, 787, A350, truly composite airplanes. From the engineering, do we have the technology? Do we have the human capital resources to continue to really, the next aircraft, follow on to the 737? They're already talking about it. I'm sure the Airbus is talking about the A320. Are we talking about something evolutionary or, evolutionary to the scale of 2 or 3? Or are we just, are we talking about something revolutionary or none of the above?
None of the above, in my opinion, but this is my personal opinion.
Okay.
In our company, we don't do that much commercial aviation, but in previous companies I did. And the main reason is because majority of these big companies like Boeing, Airbus, Gulfstream, they are more like an assembly line. And they have a subcontractor to do a lot of these kind of things for them, basically. And since these companies are basically driven by profit, quarterly profit, and one of the biggest costs of creating or building or designing a new airplane is certification. They try to avoid that as much as possible. And to avoid that, you have to basically not come up with a new innovative idea. Today, if you want to design a new airplane from scratch, it's going to cost billions of dollars. And by the time you get that money back, it's 20 years, basically. These are public companies. They have responsibilities to their shareholders. I can understand why they cannot do that. That's why always, defense have been the frontier of innovation. And the innovation started trickling down to commercial after that, basically. Yeah. But since defense is changing their model as well, and they're trying to, think about these as commodities and treat companies as for profit, that is really becoming a bottleneck to the future of new innovation in this country.
Yeah, well, I look at, especially when you look at, GE, Rolls-Royce, Pratt & Whitney, the 3 engine makers. And I'm not seeing any of them jump on board a new clean sheet design
Exactly.
aircraft. And then I look at, I think I look at in the newest thing in defense engines is Beehive.
Hmm.
But once again, that's for drones. So it
Yeah.
becomes all right. If you want evolutionary or revolutionary, you got to figure out we're a long way from revolutionary.
Yes, and you have to bring bunch of people that are out of box thinker, never did this before, and that's what we do in our company. Whenever we want to do something new, we don't go hire people with 20 years of experience. We bring people right off from college that never did this before, so their mind is completely free.
Which you must have been reading my mind because it was coming up to the next topic I really want to talk about.
Yes.
Education,
Hmm.
STEM, engineers, Cal Poly Pomona, great engineering school. You guys got a
It
couple of
is.
great engineering schools out in California. And then I think about NC State where I'm at. How do I put this? Are we building enough engineers or creating enough engineers? And then the next question is, are we respecting their talents long-term enough so that we continue to develop the next generation of engineers? Or are we?
Well, as a person who came to United States for higher education, I have to say this country have the best universities in the world, specifically in the engineering, with the global economy of being 10 times bigger than the second one, basically. Is there a shortage of engineer? Depending on who you talk and what major you talk, there is always people claim this is a shortage and we can use more. Universities, in my opinion, are doing a great job to do that. However, for universities to bring good students out, they need research funding, not teaching funding, because that's where the student learns a lot, grad student, PhD student. And those fundings every day is becoming compromised. As I said, again, the policy of the government is not to spend money on research and just go buy off-the-shelf product, basically, without consideration that where this off-the-shelf product comes from. Somebody needs to do the research, basically. So in a long term, if we continue cutting research at the universities in the next 10 years, yes, we are going to suffer. And as you can see, this year, specifically European universities are really beefing up, absorbing students, even from United States, telling them, hey, come to Europe and study with us and we pay your tuition and all of those things. Cost of the tuition is very high for students in the United States. And that's becoming a hurdle for a lot of people. There is a statistic that 1/3 of engineering students never graduate, and the reason is because they can afford it. They have to work and they have to pay tuition, and at some point they cannot balance that, basically. But what is the future of innovation compared to these engineers? I want to turn the question two way. I don't want to say that the companies have to take care of them only in order to stay in the industry. It's a both way street, We like also engineers that they come and their mentality is, I never graduate, basically. Every day I'm going to learn something new. I'm going to do something new. That is the only way that this ecosystem can work. Because if the company start just creating an environment that you're good as you are, and you just keep it the way it is, it's not going to be beneficial for anybody. It has to be both way. Employees need to challenge themselves. How can I be better? And that way you create an environment that the companies also find a very good incentive in order to keep you in the company and keep you rewarded constantly. And I always tell a lot of companies goes to cycles of layoff due to financial problems, totally understandable. But not many of them lay off their good employees. They fight to keep them.
How do you keep if you're a company, how do you keep that energy of that innovative energy going? I mean, you think about what do you do to keep these people excited and moving forward?
You have to do it from a couple different angles. Once you have to have all kind of a team activity, team building, listening to them. For example, one of the things we have in our company is every other Friday we get together and listen to ideas, completely wild idea. Hey, I have a new cheese cutter that can do something like that. Let's talk about it, and challenge each other. And so keeping the environment challenging. Me, as a president of the company, when they see I learned everything, something new, and I'm not behind the desk just doing my paperwork and signing sheets, they get motivated. Second, injecting new brains to the company. Bright new people coming to the company from outside, young, talented, they are energetic, and they really lift up the team, basically. Yes, they make mistakes, they're learning, but their value added to the company is more than the last time on the mistakes and learning capabilities, basically. When I'm around the young people, I feel young. So that's my philosophy.
You think about it like, the big companies, Boeing.
Yeah.
Boeing, look, I'm actually a fan. I'm going to pick on them a little bit, but I'm actually, look, I think enough people have picked on them, so I'm not going to do that. But they've got a lot of engineering talent in there. Really, really smart.
Very smart.
Folks.
Yeah.
Airbus the same. I mean, I think about these, and you're like, wow, you guys are really developing that. Is it? But I think big companies get so big that they squish the innovation. How do you keep a big company mentality small?
Right. So this is a very challenging question. I have friends work in Boeing. I never work in Boeing myself, and you're absolutely right. Smartest people, and frankly, even the processes they develop, so great, and thought about every little things. And maybe that's a problem also. But I go back to one of the things that is my interest, personal hobby of reading book on sociology, is our mind during the past 2 million years of evolution have been evolved around working in a group that are less than 120 people, basically. And because we know to know people personally in order to work with each other. And when the companies grow, that personal connection is lost. And we try to replace that with processes, basically, right? But processes are a bunch of if statements, basically, and it really doesn't create that connection, basically. So that's a problem with big companies. That's one of the reasons my boss doesn't want our company to grow more than 120 people, wants to keep it innovative. However, I work in other companies. For example, when I work in AeroVironment, the CEO of AeroVironment, Wade Nawawi, his philosophy was, yes, we are a bigger company, but we can create small cells that are based on, yes, these 50 people are like a standalone company. They have their own budget. They're responsible for this, and they are going to be measured by their success. And that's one way to do it. And if you look at it, some companies, for example, Skunk working Lockheed Martin is exactly based on that concept. It's an individual separate company inside another company, basically. But it's very hard to do something like that and to keep it, because you have a lot of also rule and regulation and HR and finance and all of those things when you become big that you have to follow.
I think in a company like Lockheed Martin, when you've got Skunk Works and you've got ITAR controls and you've got stuff that literally nobody can talk about.
Yeah.
I saw Jim Taslett on his earnings call. We took a $1.8 billion charge on a classified program. And I'm sitting there thinking about, wait a minute, you took a $1.8 billion charge on a classified program, but nobody's ringing the alarm bells.
Yeah.
So yeah, we took it. All right. There's got to be a lot of process control. And,
It is.
that's the whole, that becomes the whole, in a Boeing and a Sikorsky, et cetera, there's a lot of process control.
Yeah.
So I guess, it's.
And that comes with overhead, basically. Layers of management, layers of oversee and double checking and everything, basically.
Do you see some, in the commercial world, though, do you see where smaller companies are going to start to develop technologies that and license them to Parker, to Honeywell to, or do you think that the big companies are just
That's what they do, actually. Parker Aerospace business model, or Parker Hannifin as a company's business model, doesn't have an R&D, dedicated R&D. What they do is every year they go and look at the companies aligned with their growth strategy, and they buy them, small companies. And they spend their money on R&D this way, basically. AeroVironment is another company that bought at least 3-4 companies in the past 4 years. You're absolutely right. That's how it's going to happen. And it's becoming an incentive for a lot of small companies. And they wake up dreaming that today is the day that Boeing is going to buy us, basically. And I'm not sure if that business model for small companies is going to be productive. In my lifetime, I haven't seen it yet. So,
I think it's a little hard. I think it's a little harder in aerospace when you're talking about, versus software.
Yeah.
It's a little bit more difficult.
Yes, you're right. Software is much, much easier to survive in that matter.
Yeah. What's got you really excited about the future?
The system integration. I'm a system thinker. We have all of these great tools that we are making, communication tools, processing, AI, and everything. At some level, they are going to all get combined together and create a big system. And what is that big system is going to do? How that integration is going to happen, basically, I think that's very exciting. That's a very complex problem to solve. And it doesn't have one solution. It has billions of different ways of doing it. And depending on which way we pick, is going to determine our next 100 years as a human on this planet, basically.
What's the most exciting thing can you say? What's the most exciting thing you've got working at Swift right now?
The high altitude airplane we are working, Soul. We call it Soul, and I think there is no one in the world right now have a product like that. There are 4 or 5 companies working around the world, around the clock, putting a lot of dedication to have this product ready as a product that actually people can start and using it, companies can start using it. And for us, getting to that point that we say this is a product, it's going to be a very proud moment.
I love it.
Yeah.
I love it. Hamed, thanks for coming on. So you're out in Orange County, California, in Irvine.
Yes. Irvine, yes.
So like the
Our
hub
office
of
is in San Clemente.
the hub of like tech development out there.
It's a lot of tech development in Orange County these days. Yes, amazingly. From hardware to software, space, everything.
So Swift Engineering is the company.
Is the company.
And Irvine, California.
Swift Engineering is in San Clemente, California.
Very cool. I love it. I was on your website. It's like just the fact that you just reading about I'm like, I can't imagine you got a drone flying or just a glider.
It's a beautiful small beach city, basically.
I love it. Thanks for coming on, Hamed. I appreciate you.
Appreciate it. Have a good day.